In an experiment designed to compare two different ways of measuring a given quantity, it was desired to test the null hypothesis.
Okay.
That means that the means were equal at 0.5 interval of significance. A sample of 5 parts was measured by method A, and a sample of 7 parts were measured by B. A t ratio of 2.179 was obtained.
Okay. Yeah, so in this case, so you said 8.19, that's question 8.19?
Yeah.
Okay. So we see that alpha is 0.05, right?
Yes.
And the null and high, so let's go through this. So step one. So null hypothesis and alternative hypothesis. And alternative hypothesis, 2 different ways.
Mm-hmm.
So the means, so we say mu1 does not equal to mu2, and mu1 equals mu2. And step 2, define the statistic. So the sample size we have to look at. So we know these 2 samples, mean and size, sample size. And 1 and 1 and 2, and 1 is what? Of sample size 5 part, right?
Yep.
Yep. So sample size is only 5. So this is going to be t size. Since sample size is less than 30, this is t-test. And step 3. Oh, so t equals what?
2.179.
Yeah, that's t star, right? Yeah.
What's that? What's that?
Go ahead.
Isn't this a sample of 5 parts was measured by method A and a sample of 7 parts were method B? Is that N2? Should that be 7? Is that where you're getting 5 from? Above the sample size?
So this is 2 sample tests, 2 sample mean test. However, the sample size for N1 or sample 1 is only 5. And the other sample is only 5. So in total it's 10. But degree of freedom we have to calculate. So T here equals degree of freedom.
Okay, so I have this. So the sample size is 5 parts for method A, right? And that's what N1 is?
Yes.
And then the sample, it says the sample of 7 parts for method B.
Oh, I see. Thank you. Thank you. I totally missed that.
Okay.
Yeah. So T, 5 and 7, right?
So
when you are finding T, what you have to do is T and alpha and degree of freedom. So that has to go together. And since this is two-tail test, it has to be divided by 2. Right? So the alpha that we are going to be using is 0.05 divided by 2. That's what we have to use. So T is 0.025, comma, degree of freedom is N1 plus.
Is it 11?
Oh, N1 plus N2. 7 minus 2.
Okay, so you minus 1 for each one. Okay,
Right. So that's 10.
10.
So T 0.025 and 10. And let's see this one, T distribution. T inverse T two-tail distribution. RT. No. I'm not so sure about this. T inverse T. Oh yeah, we have T inverse two-tail test. 0.05. Degree of the freedom is 10. Yeah, here we go. This is the function that you want to do. T dot inverse function two-tail test and 0.05. If we want to do just right tail test RT 0.25, it should be the same. Oops. Maybe not. T inverse, maybe T inverse function. Probability 0.025 and 10. What happens? Yeah, the same. Oh, it's a left tail test then. I think we have to go for T inverse two-tail test. And let's put alpha as 0.05. And it'll give you the answer. Yeah. 2.28.
2.28.
All right. So step 4, we go to step 4 here.
Can you show me the formula one more time?
Yeah. T inverse two-tail.
Okay. All right.
Okay, so now step 4, compare T star equals 2.179, which is greater than T rejection value 2.28. Therefore, reject the null hypothesis. Step 5, there is sufficient evidence to state that mu1 equals to mu2. That's the answer.
Fail to reject the null. Does that fail to reject the null hypothesis?
It has to reject the null hypothesis. Oh, I see. I'm sorry. This is 2.179, right? So it's less.
Less.
Is less than, what did I say? The less than the rejection value 2.28, right? So let me see. Let me draw it for you. So this means we have T distribution here. This is T, and this is 0. And this is the rejection region, and this is 0.025, right? And this value is 2.28. Okay? And we have calculated value that's 2.179. 179. So as you can see, this one does not fall into rejection region. This is less than 2.28. Therefore, fail to reject the null hypothesis. Right. Okay. So you go there again. So fail to reject the null hypothesis. Therefore, there's insufficient evidence to state that mu1 equals to mu2. So the answer is fail to reject the null hypothesis. B is the answer.
Okay.
Yep.
Yep. Yep. All right. Well, this was great. I liked it.